In this lecture we are going to see one more question regarding a pipelining. Okay, and this question is about speed up. Okay, so we are going to calculate the speed up. I had taken the same question which we have solved in the previous one, right? So I had taken the previous question only and I extended the question to solve a speed up. Okay, so we had already seen. Okay, I will show you again. This is the same example, right? Okay, that's a 4-stage pipeline, right? So 1, 2, 3, 4, right? So for a 4-stage pipeline, and stage delay is given 9 nanosecond, 11 nanosecond, 12 and 13, right? And between a pipeline register are inserted between each stage, right? So between each stage, this is one stage, registers are inserted, right? Between each stage, register are inserted, and delay for the register is given. So that is what the question is all about. Okay, now you have to calculate the speed up for, first question is to calculate the speed up for 100 instruction. So you tell me what is the formula? What is the formula for speed up? For speed up we already knew time taken without pipelining divided by time taken with pipelining. Okay, so we had already seen that time taken without pipelining for 100 instruction is what? Okay, so I think we are already seeing that part, time taken without pipelining for 100 instructions. See, right, it is 45 into 100, right? So you can either you can solve it or you can directly see. So time taken for 100 instructions. So there are 100 instructions and each instruction is taking 45 nanoseconds. Right, each instruction taking 45 nanoseconds. So how you got 45 nanoseconds? That also we had already seen, because if you are not taking a pipelining, if you are considering non-pipelining, then what you have to do? You have to add up all the delays of the stages, right? So that is I had solved here, right? Time taken for S1, stage 1, time taken for the stage 2, stage 3, stage 4. So that if you add up, then it will be 45 nanoseconds. So that is how we got 45 nanoseconds, yes. Right, and like this we have 100 instructions. So 100 into 45. So we had already seen this. I told you, this is the extended version of the previous question. If you are not seen that question, if you are not seen that question, please visit that question and come back. Okay. Now time taken with pipelining, what would be the answer? So for one instruction, it has to go, first instruction has to go through 4 phases, right? And each phase will take some time, right? And that time we are already seen, that is for uneven delay it is 14 nanoseconds, right? Plus remaining 99 instruction, it will take one stage to complete, and each stage is taking how many? 14 nanoseconds, right? So that also we are already calculated, right? Time taken for a pipelining. See here, not this, this one. Time taken for 100 instruction we are already calculated, right? So this is the thing. How I taken 14 nanoseconds? Because of uneven delay. Whenever there is an uneven delay in the pipelining, I told you, you have to take the maximum time period, right? That is 14 nanoseconds. That's how we got time period for the pipeline, which is TC. Okay, so we had seen all those things. Okay, so I am directly doing that question. Okay, I just want to show you how to calculate speed up. That's it, right? So that's why I am telling you, just watch previous question, then you come back here. So what is the answer here? It would be 40, 45, okay, 4500 nanoseconds, and this will be around 1442 nanoseconds, right? Nanosecond cut, then you will get what? It is equivalent to 3.12. You can calculate it, okay, with calcium. right? This is for 100 instructions. Speed up for 100 instructions. Okay. Now what is the next question? Determine the approximate speed of the pipeline in a steady state under ideal condition. Okay, just mark this word, that is, it is talking about ideal condition. Okay, what is the ideal condition? I made this point. See, under an ideal condition, for every clock we might be executing one instruction, that is CPI will always be 1. Okay, so this is called ideal condition. So whenever such question comes now regarding ideal condition, it's better you don't calculate for 100 instructions. You just look for one instruction, how many time it is taking. Okay, that is not exact thing, but that is what the ideal condition means. Okay, so whenever you're calculating speed up now, this time, okay, speed up, the formula would be same, right? Time taken without pipelining and time taken with pipelining. Now time taken without pipelining for one instruction, what would be the answer? So we had already calculated. That is how you have to calculate. For one instruction it is 45 nanoseconds. So that would be in ideal condition, that would be the result without pipelining. Because 100 instruction, we are not calculating for 100 instruction, because for every clock we are getting one instruction. So you just calculate for one instruction. Okay, that is 45 nanoseconds. Right, and pipelining time taken with pipelining for one instruction, what would be the answer? Type here. Okay, we will calculate the maximum of all the stages, that is 40 nanoseconds. So we will take the ratio of both, 40 nanoseconds. Then what would be the answer? This would be equivalent to 3.21. right? So this is the answer, right? So this is under ideal condition. Remember this part. Okay, so whenever there is an ideal condition, you don't calculate for an entire instruction, just try to calculate for one instruction. Okay, so time taken without pipelining for one instruction, what would be the time taken? You just put there, and without with pipelining, what would be the time period? So you just calculate that part and you just put the ratio. Okay, then you will get the answer. Right, so this is how you have to solve both this question, right? So be careful about these questions, right? So whenever there is 100 instruction is mentioned, then you have to calculate in this way only. But whenever there is an ideal condition is mentioned, ideal condition, okay, steady state under ideal condition, then the meaning is that clock per instruction is always equivalent to 1. That means we are talking about per instruction, per clock, one instruction is coming out. Okay, so you don't have to worry about 100 instructions. You just calculate for one instruction and you will get the answer. So time taken without pipelining for one instruction and time taken with pipelining for one instruction. Then when you take the ratio, then you will directly get the answer. Okay, fine.